Chapter 7, Example 4. The U.S. Census Bureau collects data on the U.S. population. You're interested in trends on U.S. birth rates and receive the data below from the Census Bureau. Create a regression model to predict the national birth rate in a given year since 1965. We want to predict it, so I need to create the regression model. It specifically tells us that there. We know that every time we do this, we need to check the conditions, and we're going to state what model we're going to use. Before we can start any of that, we need to look at the data. So here I have a scatter plot of the data. We know how to make that now. I will have the data available to you. You can load it on your calculator or spreadsheet or whatever and work through this with me. Now, in our scatter plot, we look at it, and it looks good. Pretty linear, negative, no real clear outliers. We have some kind of weird values there, but they're not outliers. They're not that far away. Just some years where it trended not in that line. But it looks pretty good. Nothing too unusual. We can go ahead and write that up. We'll talk about the association. So, the relationship between birth year and birth rate is linear, strong. So the relationship between birth rate and birth year is a strong negative association. Okay, both variables are quantitative because birth rate is the rate of births in a year and year is a year. And no outliers are obvious. The scatter plot is linear, so I can use a linear regression model to predict birth weights. Okay, now before we do this, look at this information. Years, it's 1965, 1975, 1985. So if we do a regression, the y-intercept is going to represent the year 0. We'd find out the birth rate in the year 0, which is not very useful to us. It's way beyond the data. It's not helpful. So I'm going to shift all the data. I'm going to go back to my data. And I'm going to change this a little bit. I'm going to add a third column. I'm going to call it shifted year. Typed it right in there. And then I'm going to type an equation in this second row where it has the equal sign across. Right there. I'm going to type something in right there. Okay? I'm going to type in an equation. I want to shift everything, so 1965, the first year we have data for, is year 0. So our y-intercept would represent the year 1965. It just makes our equation look a little bit cleaner and gives us some better information. So all I do is I type the year and then subtract 1965. That shifts everything. We can do that because we know it doesn't change. It shifts all the position data and doesn't change our spread. So there's nothing wrong with doing that. So 1965 will become year 0. 1970 will become year 5, and so on. So I just type that in, I hit enter, and I don't have to do this manually. I don't have to type this all in on myself. Once I hit enter, the calculator will do the work for me. And there you go. 05 year 1985 is 20 years after 1965, so I get 20 right there. So it just does all the work for me. Okay, now we can go back and look at our scatter plot. Now nothing in our scatter plot has changed at this point because I still have the original variables. I didn't change my year. The years are still the same. If you look there in the graph, the years are still 1965 to 2005 and so on. But now when I go to the graph, I click on year and I have some new variables listed. Don't worry about the residuals and stuff yet. That wouldn't pop up on your calculator. Okay, so I'm going to change that year to shifted year. This isn't going to change your graph. All it's going to do is change the scale, change the numbers on the x-axis. If you look at the graph here in just a moment, when I pop it up there, that is the exact same graph. Nothing has changed except for the years on the bottom. And all that's going to do is make our regression line a little more clear. So now I'm going to put a regression line onto this graph. Instead of going to calculate and all that, we will use that in a moment. But instead of jumping right to that, I'm going to do a regression line on the calculator so I can see the line plotted in there. And this is something that would be really good to sketch on a problem. Sketch that line right in. So on the calculator, I'm going to do menu. Just as you can see here, menu, analyze graph, so analyze number 4, and then regression number 6. I don't have a picture of it, but once you've done that, you're going to do our normal regression line, a plus bx. I think it's the second option, but it's the same one we've been using, a plus bx. Don't do m plus bx or whatever it is, because that won't give you the correlation. So now we plot it and it puts the line in there, and it gives you right here the regression line. It doesn't use y hat, that's just the way it's calculated, but we know that has to be there. Okay, so it puts the line in for us, and we can see where that line matches up. I have some points above right here. These are a little bit below. These match up pretty well. So that's my best fit line. Now we're going to write that model out. Okay, so birth rate hat equals 18.143 minus 0.108, and that's going to use 3 decimal places on the y-intercept, so we'll go with that, and that's birth year. So it looks like for every year the birth rate drops by 0.108. So about every 10 years you'd expect the birth rate to have dropped an entire point. Now, we checked our conditions, we have our model there, so we're feeling pretty good, but remember, we always want to check the residual plot now. Always, 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 always check your residual plot. And with the graphing calculator, it's very easy to do. So I'm going to go to menu again. I'm going to do analyze once again, and now a new option popped up. Before we didn't have number 7, it wasn't lit up, you couldn't pick it. But now you can. It says residuals, and then you want to pick show residual plot. So really, let's go back to that. Okay, so really you can just press some keys, some buttons that'll write down here in just a minute for you. But I forgot to set my picture. Okay, there we go. So you can really press menu 4 7 2. You want to show residual plot. The residual squares are interesting to look at, I guess. It shows you how it's the least squares line, but it's not going to help us in the analysis. Okay, so menu 472. You're going to need to remember how to do this. Always do a residual plot. Okay, now when you do this, the graph, a new graph pops up. You'll still have your residual plot above. Okay, so we still have that to see. Right up top, there's, or not a residual, but our original graph. So right up there, up top, that is our original scatter plot with the regression line in. And on the bottom are the residuals. So now we can look, is there a pattern here? Well, I don't like these residuals at all. If you notice, I drop down, I go way down here, I go up, I go, looks kind of like there's a pattern. It's not even spread. It's not consistent. I have 2 up there. I have the same amount above and below, but they're in groups. I have 2 up here, 3 down here, 1 up there, and then these are all right on the line. So I don't like this. I really don't think a line fits this very well. So let's write up our final bit. Though the conditions have been met, the residual plot shows a pattern and inconsistent spread. I would use caution with a linear regression model. So what the residual plot does is it kind of exaggerates any outliers or any extreme values or trends we have. Sometimes it's hard to see it in the original graph, but the residual shows how far each point is off from the line. So if there's any really hidden trend or an outlier or something, it kind of makes that more obvious for us. If you notice, this is 0 right there. Here are residuals, 1, 2, 3, 4. So it's counting by about 0.5. So this only is about positive 0.1 away. This one's below more than 2 below, so that's a big difference. This one's probably an outlier here. This value from 1975 looks like it could be an outlier. It's more obvious than it was up in the residual or the original scatter plot. So I have my regression line. I'm going to be very cautious about using it.